Welcome to lesson 9.4. Today we're going to talk experimental probability. So to find experimental probability required us to look at an experiment that has already taken place and make a prediction of the probability of an event occurring based off of that experiment. The formula for finding experimental probability is the number of times the event occurred divided by the number of trials. So the number of times the experiment was conducted goes on bottom, and the number of times the event happened that we wanted to happen happened goes on top. So we still use P of event for experimental probability. The difference is with theoretical probability, we are not given an experiment that has already taken place. With experimental probability, we will be given the result of a previous experiment. So we flipped a coin 9 times and it came up heads 4 times. That part right there, that's our experiment. Okay? We conducted an experiment by flipping a coin 9 times and it came up heads 4 times. So when they ask us what the experimental probability of our next flip will be heads, well, we take the number of times we had heads in our experiment over the number of trials. So our answer would be 4/9. For the number of tails, well, if it was heads 4 times out of 9, it would be tails 5 times out of 9. So the experimental probability of getting tails would be 5 out of 9. So a normal 6-sided die is rolled 10 times, and the number 6 came up 3 times out of 10. Once again, that is our experiment. Okay? That tells us that we have already conducted an experiment, and we're going to be using experimental probability. What is the experimental probability of rolling a 6 on the next roll? Well, when we had 10 trials, 3 of them came up 6. So the probability of rolling another 6, according to the experiment, is going to be 3 over 10. Another thing we can do with experimental probability is make predictions. So instead of just finding the probability on the next roll, we could say on 100 rolls, how many 6s will be rolled? Okay? So we had a small sample. We rolled the die 10 times and we got 6 3 times. We can use that experiment to predict how many 6s we would get on 100 rolls. And how we do that is we take the probability that we found from the experiment and we multiply it by the number of rolls that we're going to have. So if we take 3/10 times 100, we would get that, according to our experiment, we should be able to predict that we're going to get a 6 30 times out of 100. Our next example is something that a lot of you will be familiar with. A baseball player has a batting average of .250. That's an experiment. Okay? Because how do we conduct batting average? We take the number of hits the batter had over the number of at-bats they've had. That's experimental probability, the outcomes that we want to have happen over the total number of outcomes that happened. So batting average is .250. What is the experimental probability that the player will get a hit on their next at-bat? So if we start at .250, that's a decimal. We want to turn that into a fraction. 0.250 turns into 250 over 1,000. We can take a 50 out of both, so divide both by 50. And we're going to get 5 over 20. We can take another 5 out of there, giving us 1 over 4. So the probability that the player gets a hit on their next at-bat is 1/4. So then a prediction, out of 160 at-bats, how many hits are they going to get? Well, to find how many hits out of 160, they'll take 1/4, which was their experimental probability, and they're going to multiply that by the number of at-bats the player will have. And if we do that, we'll get that out of 160 at-bats, the player should get 40 hits. So that's how we use a sample or an experiment to make predictions. We take the probability based off of the experiment times the total number that we're going to have in the prediction to find how many that we want to have happen. Another example of using experimental probability A basketball player is a 65% free throw shooter. That's our experiment. So out of all the free throws that they've shot in the past, they've made 65% of them. What is the experimental probability that they will make their next free throw? Well, we have to turn this into a fraction. So 65% into a decimal is 0.65. Decimal to fraction, I put it over 100. So 65 over 100, I can take a 5 out of both, and I would get 13 over 20. So the experimental probability that they will make their next free throw is going to be 13 over 20. Now for our prediction, out of the next 80 free throws, how many will they make? So we take the experimental probability that we found, the 13 over 20, and we multiply it by the number of free throws that they're going to shoot. And that would give us our answer of how many we expect that person to make out of those 80. Well, 3/20 times 80, we expect them to make 52 free throws. Okay, in our next example, in the last 15 days of school, Mr. Immerman has answered a question from Jude 11 times. That's our experiment, right there. What is the experimental probability that Jude will ask Mr. Immerman a question tomorrow in class? Well, we conducted the experiment 15 times, because there was 15 days of school, and he asked a question 11 times. So the probability that he will ask a question tomorrow is 11 over 15. Using that to make a prediction. So how many questions will he ask in the next 45 days? Okay, so again, in order to answer that, we take the probability that we just found and we multiply it by the number of days that we're going to be doing this prediction over. So we're going to take 11/15 times 45, and we are going to predict that he will ask 33 questions over those 45 days. In the last 30 days of school, Paige has asked Mr. Immerman if she could go get a drink 14 times. Again, that is our experiment. What is the experimental probability that Paige will ask to go get a drink tomorrow? Well, once again, we had 30 days for our experiment, and 14 times she asked to go get a drink. So we're at 14 over 30. We can simplify this down by taking a 2 out of both. So the experimental probability is 7 out of 15. The prediction, how many times will she ask in 90 days? So again, we take the probability that we just found and we multiply it by the 90 days that we're looking to predict. And if we take 7/15 times 90, we're going to get that she is going to ask 42 times in the next 90 days to go get a drink. In the last 5 days of school, Della used her phone 4 times in class. Okay? That's the experiment right there. What is the probability that she will use her phone again tomorrow? So out of the 5 days the experiment took place, she was on her phone 4 times. We can't simplify that down, so the experimental probability is going to be 4/5. So now we're going to use that to make a prediction. So how many times will she use her phone over 35 days? So we take the probability of 4/5 and we multiply it by the 35 days that we're going to conduct our experiment, and that should tell us that she will be on her phone 28 out of the 35 days. So go ahead and pause the video and find the experimental probability that Lacey will be sitting in front of the door before class tomorrow, as well as predicting how many times she'll be in front of the door in the next 100 days, and then hit play and see how you did. You should have gotten that the experimental probability is 17 over 20, and that over the next 100 days we expect her to be in front of the door 85 days out of 100. Okay, so for the check-in in class, you're only going to have to do the first part of this. You're only going to find the experimental probability. The prediction there, that is for the menu project. So when we are using our experiment to make a prediction, this is how we do this, these prediction problems on the bottom of these screens. So make sure you pay attention to those so you can use it in our menu project for Chapter 9.